Hello everyone, let's look at Leetcode question 876, middle of linked list. This question is easy, and it has 10.9 thousand upvotes and 333 downvotes. Given the head of a linked list, singly linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node. Okay, before going into depth into these examples, let's look at the constraints. The number of nodes in the list is in the range 1 to 100. And the values of the nodes are between 1 and 100. So let's look at the examples. Okay, so here's the code. This is very often reused for a number of different problems to find the middle of a linked list. So we first define the fast and slow to be the heads. So the initial input value of the head linked list, the first node, and then we create a while loop to check if the fast node exists and the fast.next node exists. If it does, we can increment the slow.next by 1 node, and we increment the fast node by 2 nodes. And then we return slow. Slow will be the middle point. Okay. For this first example, we define slow and fast to be 1. Okay, and then we do the while loop while fast, which is 1, and fast.next, which is 2, exist. We proceed. Okay, yeah, we can. So slow becomes slow.next, so slow becomes 2, and fast becomes fast.next.next, so that is 3. Okay, and while fast, which is 3, and fast.next exists, this is true. So in this next while loop iteration, we're going to say, okay, slow.next once more, and fast.next.next. So fast is all the way here now, and slow is at 3. And then we do the while loop once again and check if fast, 5, that's true, and fast.next, that's false, there's nothing after node 5. So we exit this while loop and return slow. So 3 is the middle node here. Okay, let's check out this example. Slow and fast are both starting at 1, head value input, while fast and fast.next, so 1 and 2 exist. Slow equals slow.next, so slow becomes 2, and fast.next.next is 3, so fast becomes 3. While fast, 3, and fast.next, 4 exist. Same thing. Slow becomes 3, fast becomes 5. Okay, so we iterate once more, because fast exists, and fast.next exists. Okay. Slow equals slow.next in this case, then. And fast equals fast.next.next. So fast is here, where there is no node. So then this while loop has to be finished because there is no fast node and no fast.next node. So we return slow. Slow ended up being at node 4. Now let's look at this little example. So we have slow and fast to be both at 1, and we check while fast and fast.next. That's true. We iterate then slow is here and fast is here to start out, and then slow.next becomes 2, and fast.next.next becomes a non-existent node value somewhere, and this allows it so we exit the while loop because the conditions are not met, and we return slow, so that is 2. That's 2 then. Okay, let's check the solution. And it works. Amazing, it works. So the time complexity is O of n, where n is the number of nodes and the linked list. So we iterate through every single node once and move the slow pointer 1 step at a time and the fast pointer 2 steps at a time. So that's O of n time. The space complexity is O of 1 because we're only using a constant amount of space for extra space to store the slow and fast pointers. We're not using any additional data structures to grow the input size. So that's it for this question. Thank you for watching.